So, to continue with the motion of charged particle in crossed electric and magnetic field, let us discuss some more cases. Let us say we had done two cases, in fact we had done two cases. This is our electric field in y direction and this is magnetic field in z direction, and then one case was where the particle was released from here. The another case we discussed was when the particle was initially going in this x direction with a velocity, initial velocity which was e by 2b, which was v naught by 2. When this u was 0, initial velocity was 0, in that case we saw that the motion was like cusps, cycloid, like this. Whereas when u was v naught by 2, e by b, this is v naught by 2, then we saw that our curve was like it goes and beautifully it touches and then it goes like this, smooth. If you further increase this velocity, the same pattern will be there, only thing is that this will be spread over. So, this is the kind. Now, another very good example is, special example is when you take this u itself as e by b. If you take u as e by b, that means v naught, what happens? So, that means what we are doing is we are sending this particle with velocity, initial velocity, which is this v naught. This is the kind of thing that we are now discussing. So, we can go to S prime frame as usual and see what happens, but it is very easy to analyze from S also. If you want to go to S prime, then what will happen? This S prime, as you know, this S prime moves with a velocity of v naught. At t equal to 0, the origin is here, this axis is here, this axis is here, and then it slides on this frame. I am only showing it here, but it is sliding on this. The x axis is sliding on x axis and y and z are parallels to these y and z. Now, if the frame is also going with the velocity v naught and the particle is also going with the velocity v naught in the lap frame, then in S prime frame the particle is at rest. From the lap frame the particle is going with velocity v naught and then this S prime is going with velocity e naught. That means initially at t equal to 0 the particle is at rest here. The particle is at rest. So, in S prime frame, this is I am drawing from S prime. So, in S prime frame, x prime here, y prime here, z prime here, there is a magnetic field, but there is no electric field. There is a magnetic field, but there is no electric field in this frame. And if the particle is placed here at rest, t equal to 0, t equal to 0, the particle is placed here at rest, there is no reason why the particle will move. There is no electric field and magnetic field does not exert force on a particle at rest. So, no force acts, no acceleration, it will stay there. Once it is here at t equal to 0, it will stay here for all time to come. So, as seen from S, what you see is if it is at the origin of S prime and the whole S prime is moving, then this particle is also moving in a straight line with this velocity v naught. It is easy to see it from the S frame also. If you work from S frame in this particular condition, if you work from S frame, do not go to S prime. you can see what is the net force at t equal to 0. So, at t equal to 0, the force is q E plus V cross B, because in S frame you have electric field as well as magnetic field. So, you have to write this. Now, q times E is equal to q times E, that is all. And if this q V B, V and B are in perpendicular directions, V is here and B is here. So, the magnitude will be just q into V into B, and this will be equal to q into this V is E by B. This velocity is E by B. So, I am still talking in at time t equal to 0, and this multiplied by B, and that is q E. So, the electric force and the magnetic force, they have same magnitudes. What about directions? Look at here, if it is positive charge, the electric force is in this direction, and if it is positive charge going this way and your z axis is coming that way, then you can work out what is V cross B, and it is in the downward direction. Or you can use these vectors V cross B. V is V naught I cap, right? V is V naught I cap, this V, and cross B, B is in Z direction, so it is B K cap. So, that will be V naught B, and it is minus J cap. Minus J cap means negative Y direction. So, magnetic field is in this direction, electric field is in this direction, and the magnitudes are equal. So, the net force is 0. So, this net force is 0. If net force is 0, it will not accelerate, that means it will continue with V naught, and if it continues with V naught, then whatever is at t equal to 0 for all time to come, the same story, and therefore, it will just continue with the original velocity as if there is no electric field, as if there is no magnetic field. But this is only when this velocity is E by B. If the velocity is less or more, then it will go on some curved path. You have already seen, if the velocity is less, if it is 0, it goes like this. If the velocity is not V naught but less than V naught in this direction, then it goes like this. So, this kind of arrangement of electric and magnetic field, which allows only one particular velocity of that particular charged particle, remember q and m are there, there is no force, and for all other velocities there is force. That means you can use this as velocity selector. It is called velocity selector. If you have a region, in which you have this kind of electric and magnetic field, magnetic field of this kind, and then in this region, if you are sending particles of different velocities, then only one kind of particle will go straight. Suppose this is the region in which you have electric and magnetic field, and this is the line. Initial velocity is this way, and it is the line. So, only the particles which had velocity E by B will come this way. If the particles are having velocity less or more than this, then it will deflect and will go somewhere else. So, you have selected from this chunk where several velocities are there, you have selected this particular velocity. So, in that sense it is called velocity selector and used in several applications. Now, let me take another example where the initial velocity is more than this E by B. We had taken the case where initial velocity is less than V naught. We have taken the case where it is not only less than V naught, it is 0. Now, let us take a case where this velocity is more than v naught and see what happens. So, let us see. Let us take a specific case. Let us say that initially, at t equal to 0, the particle has a velocity u which is 2 times v naught. It is like this. And in what direction? In x direction. So, u initial velocity u is 2 times v naught and then I cap. This is from the lap frame. This is from the lap frame. What happens in S prime frame? What happened in S prime frame? This is our S prime frame. So, from S prime frame, and remember S prime frame is that same which is moving with respect to S frame with a velocity e by b in positive x direction. So, in that frame the initial velocity at t equal to 0, what is the initial velocity? So, in S frame the particle is going with a velocity 2 v naught. In S frame S prime is going with velocity v naught. So, particle is going with velocity 2 v naught, S prime is going with velocity v naught. So, from S prime if you see this particle is going with a velocity v naught in positive x direction, right. In S, if this is going with v naught and the particle is going with 2 v naught, then if you see from this S prime, you find that the particle is going with v naught in positive x direction. So, in S prime frame the particle is going in this direction with a velocity v naught. Now, first thing to notice is that there is no electric field, you have magnetic field in this direction. What is the direction of the force this time? Q v cross b, Q v cross b. So, you can use that vectors Q v cross b, Q and v velocity here is v naught, that is v naught I cap, and then cross this, and this is b and k cap, and it is q v naught b. We just did this, we are just repeating what we had done slightly ago, minus j cap. So, the force is in negative z direction, it will bend downward and not upward. So, y will be negative, y will be negative, it will bend this way, it will start its motion this way. Okay. And then usual is only magnetic field, so it will go in a circular path. So, it will go in a circular path, it will be a circle of this kind. What will be this radius? What will be this radius? This radius r will be m v by q b, that is our equation, and this is m v naught by q b. This is the radius, and angular velocity is q b by m. So, what are the equations? It is going in the circle of radius capital R. Capital R is m v naught by q b, which is in fact v naught by omega, because this q b by m is omega. With this radius it is going in this circle, angular velocity is omega. So, at time t the particle is somewhere here and this angle is omega t, particle is somewhere here and this angle is omega t. This is the position of the particle in S prime at time t. What is the x coordinate? X coordinate will be x prime equal to this length. And how much is this length? If this is r, this radius is r, this is omega t, then this length is r, sine omega t, positive. So, x prime is r sine omega t, that is v naught by omega and then sine omega t. What is y coordinate? Y prime, this is y prime, this is the whole, this whole length is capital R and then minus this length, this is your y coordinate negative. So, in this length is r and from this you subtract that, this is r cos omega t. So, it is r minus r cos omega t with a negative sign. So, this is equal to minus r is v naught by omega and 1 minus cos omega t. Y is all the time, y prime is all the time negative, because this is always positive or 0. So, it is all the time negative or 0. Previously, when we were discussing v naught by 2 or 0 initial velocity, then this y prime was all the time positive. Now, this y prime is all the time negative and sometimes becoming 0. So, this is it. What is x? What is x? Go back from s prime to s. So, once again you have to add v naught t, so simple. So, x is equal to v naught t and then plus x prime. X prime is here plus v naught by omega sine omega t. Let us write this as v naught by omega t and v naught by omega sine omega t, and then we take this v naught by omega common and write it as omega t and plus sine omega t. This is x and y is here minus v naught by omega and 1 minus cos omega t. What will be the shape of this curve? What kind of path it will follow in the lap frame? So, we will just do this Desmos analysis and see what kind of path this will be. So, for our Desmos, we will take this as 1 and omega t will be our parameter, because the scales, only the scales are different, whether you plot t or you plot constant times t, the shape remains the same. So, for Desmos we will be using x is equal to t, this will be 1. So, t and plus sine omega t, so sine t, and y will be minus of, this is 1, so 1 minus cos omega t. Alright, so let us go to Desmos. So, for x coordinate I have t plus sine t. So, let me write here, I put this parenthesis and then t plus sin sine and then t. So, this is our x coordinate and y coordinate is minus of another parenthesis 1 minus cos cos and t, right. We are writing in t, this was omega t on the board, but then we are plotting in terms of omega t. Your x axis is omega t and therefore, but this software recognizes that just as x. So, we are writing this t is a parameter, this is a parametric equation, and let us say t goes up to, let us say 25. Yes, so this is the kind of path, this is the kind of path. Remember, this time we have sent the particle from the origin of the lap frame with a velocity towards the positive x axis, and the velocity was 2 times capital E by capital B, 2 times v naught. In S prime frame we had velocity V naught in the positive x direction, it was a circle, but as seen from lap frame, it is again cusp, it is again cusp at these points, it is again cusp, and this time as you can see it will be pi here, this is 1, this is 5, remember. So, this is 1, this is 2, this is 3, and this is 3.14 at pi, omega t equal to pi, you have a cusp, then omega t equal to 3 pi, you have a cusp here, then 5 pi and so on. All right. So, it is the similar kind of graph. Initially we started with 0 velocity of the particle in lap frame, and then we saw that it makes cusps and so on, and here again the same kind of graph you are seeing. In S prime, you have speed of the initial speed of the particle V naught. Initially it was in negative x direction, this time in positive x direction. So, the final nature of the graph is the same, only thing that it is now forming below the y axis, not above the y axis. Okay. In S prime, the velocity of the particle, initial velocity of the particle is in the positive x direction and V naught. In the previous example, when this charged particle was released from rest, in S prime it was going with the same speed V naught in the negative x direction. There also we saw it was cusp like graph. In fact, whether you send it in this direction or this direction in S prime, if speed is equal to V naught in S prime, then you get cusps, and if the speed is less than this V naught, then you see those smooth curves like this that we had done when we took initial velocity as half this V naught, then we had seen that you get this kind of curve. Now, another very interesting part of the particle results if you send the particle in the lap frame initially at t equal to 0 along the x axis, but with a speed such that in S prime the speed of the particle is more than E by B. In that case, the nature of path is very interesting. So, let me do that. So, let us start a new configuration in which we have the same situation. In x direction no field, in y direction you have electric field which is E times j cap, and in this z direction we have B field which is B times k cap, and V naught is E by B. This is a charged particle q here, and we give it an initial velocity in positive x direction, and let us say the velocity is 5 by 2 times E by B, 5 by 2 times V naught. If I go to S prime frame which is moving with respect to this S, this is our lap frame, and in the lap frame this S prime frame moves with velocity V naught I cap, V naught is E by B. Remember, this origin is coinciding with this origin at t equal to 0. I am drawing the figure here, but this S prime has this x axis of S prime is coinciding with this x axis, and similarly other axis at t equal to 0 origin is crossing. So, that is the situation. So, in this frame, if I go in this S prime frame, you know electric field is 0 in this frame, electric field is 0, so only magnetic field is there, x prime, y prime and z prime, and the initial velocity of this charged particle q is phi by 2 v naught and minus v naught. So, this will be 3 by 2 v naught. So, this particle initially at t equal to 0 is going in this direction with a speed 3 by 2 v naught. Phi by 2 v naught minus v naught. So, in S prime frame it is going at 3 by 2 v naught, more than v naught. My purpose was to take a situation so that in S prime the speed turns out to be more than this E by B, it is 3 by 2 times that. So, it is more than. What is the direction of magnetic force Q V cross B? What is the direction of this? Q V is 3 by 2 times V naught, and then in I cap direction, and cross product B is B k cap direction. So, it is minus j cap direction. This is minus j cap direction, 3 by 2 q v naught b in minus j cap direction. So, it will turn downward, it will be a circle, no electric field, only magnetic field, uniform magnetic field, particle projected perpendicular to the magnetic field. So, it has to be a circle and downward. So, it is like this. It is like this. This will be the path. This will be the path in S prime frame. This will be the path. And the center of the circle is here. This is the radius r. And what is the radius? What is the radius? R is equal to m times speed, and the speed is 3 by 2 v naught. So, m times 3 by 2 v naught and divided by q times b, that is the radius, and qb by m is omega. So, it is 3 by 2 v naught by omega. This is the radius, and here is the center. What happens at t time? Where is the particle at time t as seen from S prime frame? So, the angular velocity is qb by m, omega is qb by m, this is the angular velocity. So, this is the angular velocity of this motion. So, at time t the particle will be here and this angle turned is omega t. This angle turned is omega t. That is the meaning of angular velocity. So, here the radius, and this radius turns through this omega t, draw a perpendicular on the y axis and write what is x coordinate and what is y coordinate. So, x coordinate will be this much, x coordinate will be this much, and that will be x prime equal to capital R, this is capital R times sine of omega t. So, capital R times sine of omega t. Many of the things I am repeating, we have done all these type of calculations for the previous examples, but nevertheless let us do that. And what is y prime? Y prime is negative. So, negative, and this is y prime, this is here the particle. So, x coordinate and y coordinate, x coordinate and y coordinate, this is it, and that will be total capital R and minus r cos omega t, right. R cos omega t is this much, from capital R you subtract this, put an extra minus sign here. So, this is minus r 1 minus cos omega t. So, we have gotten x prime and y prime. Go back to the lab frame, write the x and y coordinates from the lab frame, and very simple, x will be simply x prime plus v naught t, and that will be r sine omega t, or let me write this v naught t first. V naught by omega t, that is how we write V naught t, and then plus x prime, which is r, and what is r? R is 3 by 2 V naught by omega. So, 3 by 2 V naught by omega, this is r, and then we have sine of omega t. So, sine of omega t, and you can take this V naught by omega common, and then you get omega t here plus 3 by 2 sine omega t here. Alright, and y is same as y prime. So, it is minus r, r is 3 by 2 V naught by omega. So, 3 by 2 V naught by omega, and then we have 1 minus cos omega t, 1 minus cos omega t. We have solved the problem. We have solved the problem. We know where the particle is as seen from the lab frame. As seen from the lab frame, where the particle is at time t. At time t, this is the x coordinate and this is the y coordinate. But then algebraically, yes, but what is the shape of the path? So, we go to Desmos, and for that we will write x is equal to, we will take V naught by omega as 1, omega t will be our parameter. So, we will write this t here. So, this is t and plus 3 by 2 sine omega t. So, sine t. Right, x is equal to V naught by omega, we take it as 1, and here we plot against omega t. So, the independent parameter t is written for omega t, t plus 3 by 2 sine t, and y is equal to minus 3 by 2 here. V naught by omega is 1, and this is 1 minus cos t, 1 minus cos t. This is what I will feed in that Desmos slot. Let us go to Desmos. So, here is that Desmos screen, and in the box we will start with this bracket parenthesis. When you write parametric equation, you have to write in this format: t plus 3 by 2, that is 1.5. So, 1.5, and then sine of t, sin sine of t, comma, and then we write y is minus 3 by 2. So, minus 1.5, and then inside this another parenthesis 1 minus cos of t. This. All right. So, see what is going to happen. I am giving the value of t starting from 0 up to, let us say, 25, and I give it 25, and you see what kind of path it follows. We have started the particle in x direction with a velocity which was 5 by 2 times of v naught, and then it turns downward and it makes loop here, a loop here, not cusp and not a smooth minima. So, it makes a loop here, and then it goes on repeating, and this bottommost point is again pi, this is 3.14, right. Then this is 3 times pi, this is 5 times pi, and so on. You can play with it. You can, I have taken some examples. In this particular case, my velocity in lap frame, initial velocity was 5 by 2 times v naught. You can take other values and see from Desmos what kind of paths this particle takes. Okay, so that much for the motion of charged particle q in crossed E and B fields. This method is very, very effective and very, very instructive. Go to S prime frame where the electric field becomes 0, it is only magnetic field and the path is circle. Convert that path in lap frame and you get your solutions. We will do something else next time.